Hello, my name is Zachary Zhu, and today I will be talking about the 2003 BC FRQ number 2. So we are given that there's a particle that starts at point A on the positive x-axis at time t equals 0 and travels along the curve from A to B to C to D as shown above on the graph. The coordinates of the particle's position, x of t and y of t, are differentiable functions of t where x prime of t equals dx over dt, which equals negative 9 times cos of pi t over 6 times sine of pi times the square root of t plus 1 divided by 2. And y prime of t equals dy over dt, but is not explicitly given. At time t equals 9, the particle reaches its final position at point D on the x-axis. Part A asks us if at point C is dy dt positive, at point C is dx dt positive, and we need to give a reason for each answer. For part A of the FRQ, they ask us to determine if x prime of t is positive and if y prime of t is positive at point C. Then we need to justify our answers. While we can use the equation to determine x prime of t, we do not know what the t value is at point C. As a result, we must use the graph to determine the values of x prime of t and y prime of t. We are given that the function travels from point A to point B to point C to point D. Looking at the graph, we see that at point B to C and from point C to D, the particle is moving downwards and to the left. Since the function y of t is going downwards from point B to D, dy over dt is not positive. Since the function x of t is going leftwards at point B to D, dx over dt is not positive either. You receive 1 point for stating that dy over dt is not positive with an appropriate explanation. You receive another point for stating that dx over dt is positive with an appropriate not positive with an appropriate explanation. Part B asks us, the slope of the curve is undefined at point B. At what time t is the particle at point B? Basically, part B wants us to find the value of t that makes the slope of the curve undefined at point B. The crucial component to this problem is realizing that they want us to find the values of t that makes x prime of t equals 0 within the appropriate interval 0 to 9. We can use basic algebra to determine the values that makes x prime of t equals 0. X prime of t must equal 0 when cos of pi t over 6 equals 0, or when sine of pi times the square root of t plus 1 divided by 2 equals 0. Through some algebra, we get that t must equal 3, 9 to solve the first part, and t must equal negative 1, 3 to solve the second part. But since negative 1 and 9 are not within our domain, we discard those answers. Therefore, the slope is undefined at t equals 3, which is point B. You can also graph x prime of t equals 0 on your calculator on the domain 0 to t to 9 and find the zeros there. However, when your calculator tries to compute the zeros, it will get an error. Nevertheless, looking at the graph can be a helpful way to determine where x prime of t equals 0, aka t equals 3. 1 point is awarded for realizing that the function is undefined at point B where x prime of t equals 0, since when x prime of t equals 0, which is in the denominator, that would make the slope undefined. 1 point is also awarded for finding the right answer, t equals 3. Part C asks us, there is a line tangent to the curve at the point x of 8, y of 8, and has the equation y equals 5/9 x minus 2. We have to find the velocity vector and the speed of the particle at that point. You're given the slope for the part C at t equals 8. Then, you have to use the x prime of t equation to compute x prime of 8. Then, you use the fact that the slope equals dy over dx, which equals dy over dt divided by dx over dt to solve for dx dt. We know that the speed equation for vectors is the square root of dy over dt squared plus dx over dt squared. Once we plug in the values of dy dt and dx dt into our equation, we can answer all parts of this question. We can use the equation to get our dy over dx. We know from the equation that 5/9 must equal the slope, since that's the definition of dy over dx. Then we can find dx dt by plugging the value of t equals 8 into our equation, and we get negative 9 over 2. dy dt can easily be found by multiplying dy over dx by dx divided by dt, which gives us 5/9 times negative 9/2, which equals negative 5 over 2. Therefore, we know that dx over dt equals negative 9 over 2, and dy dt equals negative 5 over 2. So the velocity vector must be negative 9 over 2, comma, negative 5 over 2. And the speed is equal to the square root of dy over dt squared plus dx over dt squared. So the speed must equal the square root of negative 4.5 squared plus negative 2.5 squared, which equals 5.148. Remember to have exactly 3 significant figures in order to receive full credit for this question. You get 1 point for finding x prime of a. You get another point for finding y prime of a. 1 point is given for correctly calculating the speed at t equals 8. And part C has exactly 3 points. The last part of this question asks us to find how far apart are points A and D, the initial and final positions respectively of the particle. Since we are not given the explicit function for the particle's motion for part D, we have to use the tools we are given, namely the x prime of t function. Using some integration, we can solve for the displacement. X prime of t has a horizontal velocity of the particle. Since y of 0 equals 0 and y of 9 equals 0, the distance that the particle is displaced is equal to the integral of t equals 0 to t of 9 of x prime of t. As always, we will set up our integral, then plug it into our calculators. We can ignore the y value since that doesn't change in this instance. So basically, we take the absolute value of x of 9 minus x of 0, which is the total displacement, and we take the absolute value because we're finding the total change, we're not finding the direction. And we know that is equal to the absolute value of the integral from 9 to 0 of x prime of t dt, which once we plug it into our calculators, we get 39.255. And once again, remember you need 3 significant figures. 1 point is given for correctly setting up your integral, and the other is for correctly calculating the value. So remember, even if you can plug it directly into your calculator, you still need to set up your integral. So some additional resources that you can use is the College Board Vector Practice / Teaching Material, which they give as a lesson plan. The AP Calc BC FRQ 2011 number 1 and AP Calc BC FRQ 2012 number 2 are both good practices for vector FRQs. And then the last resource that I recommend that you go to if you're still having trouble is a collection of vector FRQs that are put together by a teacher of lmstd.org. This problem does not have any really hard integration calculations or anything like that. Instead, the hardest part is understanding what they are asking for and how to go about to find a method that will yield the appropriate solution. You need to know the relationships between dy over dx, dx over dt, and dy over dt in order to find the total distance traveled, the speed, the velocity, and that kind of thing. Memorize the formulas. That is one of the most important things you can do in order to solve these questions. The average score for this question was 4.11 over 9 points. That means the majority of people got less than half of the points for this question. If you encounter a problem like this, take a deep breath. Find out what they're asking, then you can find the solution pretty easily. Remember when you're finding the total displacement, they want an absolute value change because it's total displacement, they're not asking for direction. Also, remember that you have to set up your integral in order to receive full credit for these kinds of problems.